Welcome to the Mineral Exploration Stage series. In this video, we will explain the method of sampling from streams and valley, which is the first stage of mineral exploration. There is a separate video on soil sampling method available on the channel. Then the rock sampling stage, followed by the trenches stage, and then the drilling stage with its various type, whether core or RC. Finally comes the mining stage or evaluation, extraction, and processing to obtain the desired metal. In this video, we will cover all the stream sampling stage in 5 phases, which altogether explain how to prepare a complete action plan for stream sampling in the exploration block. This includes everything from using software in the office to conducting the fieldwork and sending the samples for analysis. Let's get started.
A special thanks to my esteemed friend, geologist Tariq Al-Khawat, for your valuable contribution to the video content. The main purpose of this method is to identify and determine the mineral concentration zones by collecting samples from streams that contain various mineral elements, which originate from different rock formations. These formations are exposed to weathering due to rainfall, causing the minerals to deposit in the surrounding streams. By analyzing stream samples in certified laboratories, we can identify the primary source of these minerals, allowing us to conduct further exploration stage on these mineral resources. In this method, we take samples from secondary, subsidiary, and tertiary streams, but we avoid primary streams as they are prone to contamination and will not provide accurate information about the source of the mineralization. Phase 1. Working on the aerial image of the exploration area. We start by requesting a TIFF image of the desired area from any satellite company. The image is called SRTM, which stands for Shuttle Radar Topography Mission. This image shows the DEM, short for Digital Elevation Model. We then process the image using ArcGIS software to analyze it and identify the streams in the area. Let's proceed with the steps. First, we open the ArcGIS program. Right click, go to Data Frame Properties, then select Coordinate System and choose a specific coordinate system for the area, which in this case is 36N. Then go to General, Display, make it UTM, then apply, OK. Number 2, add SRTM image by selecting Add Data. E. Move YouTube Exploration Stream Stage. Choose SRTM, Add. Yes. Number 3, open ArcToolbox. Choose Spatial Analyst Tools. Then select Hydrology. Number 4, select Fill. In the input field, add the SRTM image. Click OK and wait for the creation of the fill DEM image. You can track the progress at the bottom of the screen. Number 5. Next, select flow direction. In the input field, add the fill, digital elevation image. Click OK and wait for the flow direction image to be created. Also, you can track the progress at the bottom of the screen. Number 6. After that, select Flow Accumulation. In the input field, add the flow direction. Then click OK and wait image to be created. Note that This process may take some time. Okay, very good. Number 7, right click on flow accumulation, choose properties, then select Symbology, then stretch and choose standard deviations. Apply. OK. Since the DEM image covers a much larger area than the desired exploration block, we will crop the required area. Follow these steps. Step 1. Prepare an Excel file with the coordinates of the corners of the exploration block. Step 2. From the file menu, add data, add XY data. Select the Excel file and drop the point into the map. Boundary, add. Sheet, add. OK. OK. Adjust the size and color of the samples to make the points more visible by right-clicking on the sample and editing it. From here, sample selector, make it, for example, green color, size, for example, 8. OK. Step 3 is the ArcCatalog. Your folder icon here. Select a folder to save the shape file. For example, we select this YouTube exploration stream, right click, new, shapefile, name it, for example, Moody, block, feature type, polygon, and define the coordinate system by clicking on edit, import, and selecting the desired digital elevation model image such as SRTM. Add. OK. OK. Step 4. From the editor menu, click Start Editing. Choose the desired block to be drawn. Moody block. OK. And select Create Features to draw the required polygon. Create Features. Moody block. Then draw your polygon. One click here. One click here. Double click at the last point to close the block. Then from editor, choose Save Edit. Then stop editing. Take the block to hello from here. Fill color, no color. OK. Step 5. From ArcToolbox. From here, choose Data Management Tools. Go to Raster. Raster Processing and choose Clip. In the input field, add Flow Accumulation. And in the output field, select the shape file for the exploration block, Moody block. Then click OK and wait for the cropping process to complete. The clip file will appear in the content list. Step 6. Deselect all layers in the content box, leaving only the layer you are working on. OK, very good. Step 7. Right click on the desired file, choose Properties, and then choose Standard Deviations. Apply. OK. You should now see the streams more clearly in the exploration block. Very good. Phase 2. Identifying stream samples points to be collected in the secondary, tertiary, and minor streams, and creating a shapefile to convert it to Excel for field work. Step 1, open ArcCatalog. Select your working folder, Moody Exploration Stream Stage, right click, new, Shapefile, for example, Moody Stream Points, Features, Points, from Edit, Import, choose SRTM, add, OK, very good. Then click Editor, start editing, select Moody block, OK. Select Create Feature, Moody Stream Point, and begin placing points in the exploration area, focusing on the secondary, tertiary, and minor streams as mentioned earlier. Adjust the point samples to make them more visible. For example, we can choose here, and here, and here. Also take sample from here. Also take sample from here, and here, and here. Okay, that is enough. Adjust the point samples to make them more visible, such as, for example, choose yellow color, make size, for example, 8, choose a square. Okay, very good. Then from editor, save edits, stop editing. Step 2, ensure the editor is not active. Right click on the created shape file, choose open attribute table. From the table options, from here, table options, click add field, name it, for example, X, use long integer. Okay, and add another field for Y coordinates. Table option, add field, name it Y, long integer. Okay, close the window and go back to editor, activate it, start editing. Then right click on the shape file, open the attribute table again, and right click on the X column, choose calculate geometry. Yes. Okay. Yes. Very good. And do the same for the Y column. Right click, calculate geometry. Yes. Property, choose Y coordinates. Okay. Yes. Very good. Step 3, export the points as an Excel file. To do this, deactivate it. Editor, right click on the shape file, select open attribute table, activate any option, for example, put it here, and from table options choose export output table. From here, choose your folder, output table, for example, choose our folder Moody YouTube Exploration Stream. Save type as D-base table. No. After save it as a D-base file on your device, then open your folder and open new Excel file worksheet. New worksheet, for example, name it Moody Stream Coordinates. After opening new Excel sheet, choose DBase as the file type. For here, file, open, and go to your folder, maybe YouTube Exploration on stream. Then choose from here. You can choose all files, or you can choose DBase files. Maybe stream point. Open. Very good. And rename the samples you want to collect. ID here, for example, make it sample number 1, sample number 2. We have 27 points. Okay, very good. You can now export the points to a GPS device for field work, or import the Excel file back into the ArcGIS program to reproject the point with the new names. Phase 3, sample collection. A sample can be taken for every 10 square kilometers, classified as low scale, or one sample for every 5 square kilometers, classified as medium scale. Alternatively, one sample can be taken for every 1 to 2 square kilometers, classified as high scale. The sample collection process involves the following steps. Step 1, scrap the surface layer and take samples from the clay layer. Step 2, sieve the sample through a -63 micron sieve. Step 3, package the sample in a paper envelope, label it properly, and take a weight of approximately 300 grams. Split the sample into 150 grams for lab analysis and 150 grams as a backup. Phase 4, send the sample to an accredited laboratory and wait for the results. After receiving the analysis, reprocess the results using the threshold value and previous study. Phase 5, plot the analysis result onto the exploration plot. This will help identify the mineralized areas and allow for the continuation for further exploration stage. There is video on the channel that demonstrates how to plot the analysis results on a map to simplify the analysis. You can check it out. Thank you for watching the video. Please consider subscribing to the channel and sharing the video. Stay safe and see you in another video from the mineral exploration stage series. Bye.